Hello, welcome back to BlenderSushi Live Noding. So continuing with our ASCII art generators, we learned how we can use animation nodes or Sverchok to generate it, like random numbers or random alphabet characters. Random things is still something that we're gonna do now, but we're gonna do it slightly differently. Here I'm using Sverchok, and what's happening here is actually I'm using this script node by one of a Sverchok developer. This is actually a little bit more advanced, actually more Pythonic, I guess, because everything happens inside this script node. So what's going on here is actually this guy is kind of generating a single text stream that is kind of making a bunch of text, and the text actually have this inline go to the next line thing. So what we have in the scene is only a single text object. This is what I said when this is actually much more efficient, and this is more I guess this is more Pythonic. Just like if you're using Python and kind of printing like a stream or like a string of line of random number, and maybe you make it like in this case with my setup at the moment it's generating 5 by 5, so it's generating 25 characters over 5 lines of text string. And so yeah, what's going on here is actually Sverchok is generating random number generators, the total of 25 characters or 25 numbers, and based on that 25 numbers, it's like a string data that goes into script node here, and inside the script node this Python script is kind of doing the like a splitting of the text. So instead of having all these numbers in one single line, it's kind of breaking it into 5 lines using this return this slash n thing. Just go to the next line, depending on how many numbers we have here. And what's interesting about this guy is that we can kind of push the value, so we are getting like a kind of like an ASCII kind of thing here. You can get some unusual character as well. So like this, if you look at it, okay, that's unusual, right? If we just have like a 0 to 9, we just have numbers from 0 to up to 9. But we go a little bit higher, we start to use like other characters map. We can go even higher and higher, and we start to get into the like the character mapping that goes beyond the normal, and we can randomize it. And yeah, I think this is really cool. And we can go higher and higher. I think 10 by 10 having 100 of this character is still pretty fast and interactive. What's interesting is I found that even with this setup, if we go like a bit too high, like 20, and start to slow down, I don't know why. This is still like a mystery for me. Maybe 400, maybe like 1,000 data array of data is actually slow. Maybe slow is like within quotation mark. This is something that's I'm still trying to understand. Why is it like slow? Can we make it a little bit faster? I don't know yet. So, but anyway, these things, this setup, this Python script for script node in Sverchok from Zeffii. This one does some cool thing underneath. Maybe I can try to understand this. Maybe I'll make this a little bit bigger. Let me try to read this. So this guy is expecting digit values coming from Sverchok random number generator. So that's I understand that 16. So this guy apparently generates like a array with the same number of characters. What I mean is you have like 16 characters here and then 16 lines going down. It's kind of supposed to be square, but you see that the spacing is also kind of important here. Let me try to fix this. I think character spacing we can adjust it here. So now this is a little bit more beautiful for our eyes. Yeah, let me. So it's with a proper spacing and proper line. This is a little bit more square, and then our brain likes square sometimes. It looks prettier for us anyway. So this is for like a random characters, but you know that this actually can go beyond just random numbers. We tried it. We tried it before. We can use vector noise. We can also use vector fractal or vector turbulence, whatever you like, and we can pipe in things like, we use the inputs that's the same value as this guy, 16 by 16, so we have like 256 numbers of array to deal with. This goes into the noise, and the output of scalar can go into like a mapping nodes. This goes in there, and then the mapping can become a value that goes into this guy. So now if we play with this number, maybe between 40 and 60, I don't know, I like playing with this ASCII character and getting like a really unusual result. If you're actually like an old school computer graphic artist, you will like to have a background that's kind of green, things like that. You can do that quite easily. So let's turn this more like a old school kind of computer. Or actually that's too colorful, but I guess that's okay. We can give this a material. Maybe just Blender material without any shading. Okay, something like that. The background is a bit too bright. Let's change this to darker color. Okay, maybe green is best. So it's like The Matrix. Do you know the movie The Matrix? Yeah, if you don't know, you watch it. It's a pretty cool movie. I think it will be soon before they make the new Matrix movie. Well, anyway, this is random noise. Somehow the color is changing. Ah, okay. This should be that. Okay, cool. So we have everything set up. We need just to play around with this number and get our character that we like. I don't know, I think we should go a bit higher and we start to get interesting looking character. Maybe try 30, between 30 and 50, maybe lower. So before the alphabet, we actually have interesting character. Let me try to scan it. Oh yeah, there you go. Between 10 and 20, we get all this weird character. There you go. And then if I remap this to the noise more properly, we're gonna get like a pattern. I think 0.2 is kind of good. You can start to see the pattern. Let's go a bit higher here, 30 by 30, so we have 900 values to play with. And here you can see the pattern of pearly noise. Maybe I need to make this ball or something. Make this higher, 50 by 50, 2500 data. If you want to see patterns, sometimes they need to be closer together. So maybe 1.5, and the line also make it smaller. something like that. And you can start to see a pattern emerging from this text. It's not, that's actually not too bad. Maybe the noise, we need to adjust the noise here. 0.6, 0.1, maybe 0.06. There we go. That's we start to see like a Perlin pattern. We can change this to cell noise. Cell noise, you can see like a square kind of pattern. Voronoi, circular kind of pattern. And you can make changes here. Okay, I actually forgot. Back to this guy. So this is the script nodes that's doing the hard job. Basically, I think it's separating the line here based on the size. So we have the squared equals size with exponential of 2 if the length of d values equals squared. MSTR character collected. Yeah, I don't, this thing a little bit difficult to explain, but I think it's separating the whole text string into multiple lines to generate this pattern. Maybe I can make the text bigger. This font is a bit hard to read. I don't know, maybe just make everything black and white, like old school computer. What else can I do here? So instead of vector noise, we can also use vector fractal. Like I said, this might give you more interesting result. There you go. You can see fractal pattern kind of being generated on the fly. So that's nice. Standard Perlin and use Voronoi. And if you like to pass in like a sampling your own image, you can do that as well. Just make a slight modification. That's gonna be it. Yeah, well, like I said, even though this is very efficient, like a single text object, and then with this text being generated and modified on the fly, apparently if I go like 10,000 or 1 million, this thing is still kind of slow. So that's still something that I need to figure out. Why is this something that's normal? Because we are actually, it's almost like rendering like a almost like rendering 1 megapixel or 2 megapixels kind of image, and these things is slow with a quotation mark. So slow, but it's not really actually slow. Maybe this is doing a lot of hard job. Again, this is like calculating. It might take a few seconds or a minute. But anyway, that's the whole process, and this is similar to previously, but instead of using hundreds or thousands of text objects, we only use one text object, a single text object, but hundreds or thousands of text string data, and this is the result. See, it's actually quite fast. Actually, if you think of this just like a rendering an image, this is what you get. Maybe, yeah, this is something to keep. Anyway, it's a nice technique. It's a fun musing of ASCII generated art. You can do the whole thing using string Python Python programming and string data manipulations. It's actually definitely one of the exercise that you can do, and it's quite fun, and definitely you need to try this if you're learning programming. Yeah, maybe in the next live noding I'll give you one more techniques to do the same thing but it's a little bit faster. I'll try. But anyway, this is it for the live noding. If you have any question, feedback, suggestion, let me know in the comment section below. Thanks again for tuning in. I'll see you in the next video. Thank you.